Sir, you are muted.
Okay, so am I audible properly?
Yes, sir.
All right. So actually, I was facing two main problems. One was the internet issue. So I think that can be resolved because in the institute we have a very good internet speed. Another one is recording. So still, I mean, recording and Meet both are not working simultaneously. So maybe I am trying to find it. If some of you can give any solution, that will be better. Okay, for me. So for the time being, okay, let us start. I will share the slides. So can you see my screen?
Yes, sir.
Okay. So yeah, so we have discussed about I mean basic things like definition of probability, axiomatic definition given by Kolmogorov. Although it is not interpretable, but it will give you a strong basis to understand the calculus on probability. Okay, and then certain properties we discussed. Conditional probability, then independent events, independent subsigma algebras, and then we define independent random variables. We have already defined a distribution of a random variable, isn't it? And then distribution function of a random variable. So we said that two random variable x and y, they are IID, means independent and identically distributed if the sigma algebra generated by them are independent, and the distribution of random variable x is equal to the distribution of random variable y. Distribution means probability distribution. Okay, so we have denoted the
अरे
probability
तुमने
distribution of a random variable x by
थोड़ा का क्या मतलब
px, and it was defined from Borel
थोड़ा सा ही
sigma
करा।
algebra br
अरे
201, right?
हमने स्केलर
And
यूज
sample
करा है
space was
तो मेरे को नहीं
full
पता कि
real
हमको पता नहीं
line.
यूज कर सकते हैं या नहीं कर सकते हैं।
Okay,
मतलब सर ने बताया नहीं क्या?
so before
स्केलर में बात ये है ना थोड़ा जल्दी हो गया,
by the way,
जल्दी थोड़ा सा
these are not
कोड
just a
लिखती हो
revision.
गया,
Okay, it is a part of your course. Okay,
पता नहीं कि वो
अरे
यूज
तो पहला
so ultimately
क्या
you are
क्या बोल रहा था नेट गया।
learning I mean significant part of stochastic processes. Okay, so there are three or you can say two important results. One is law of large numbers, and of course it is given
सॉलनेट मर
it
गया
is
पता नहीं
again decomposed in two results: weak law of large numbers and strong law of large numbers. And another one is central limit theorem. Okay, so actually roughly speaking, this law of large number says that the sample mean converges to the population mean.
अब इनने कुछ नई पॉलिसी निकाली है भाई, क्वार्टरली
So
साइज जितने फ्रेंड
here,
वापस
I
ट्रांसफर
mean,
कर
in the
देता।
sense of statistics
ये
or
नई
from
नहीं है।
statistical
अच्छा जो
point
भी
of
है,
view, what do you
मेरे
mean by
साथ पहली बार हुआ है,
population? Can
वो
anybody
दोबारा
tell
डालने
me?
पड़ेगा।
from your previous
वही
पता
मैं
नहीं
तो
क्या
सुनता रहता
knowledge.
है
Of course, I
वही
have
क्या
not
क्यों
told
होता
you
है कि ये वॉलेट में ये लोग यूज
about
करते रहते होंगे,
simple or
तब
population,
कर सकते हैं ना
right?
ये लोग तो यूज।
शायद।
इसलिए कर रहा हूँ कि वो क्वार्टरली वापस करता हूँ।
अच्छा सुनो, जो
All right.
फर्स्ट
So
क्वेश्चन है
let me just quickly
हाँ।
tell you what is
उसमें क्लासिफायर बनाना है ना हमें दो।
रुक के एक सेकंड खोल दे।
what
हाँ बना तो वही है बेस क्लास में
what
बनाना
is
है,
वो
लेकिन बताओ
हमें
population in the
हाँ
sense of statistics, right?
मेरे को ये नहीं पता कि हमको क्लासिफायर
So
खुद कोड करना
as
है
per
या
the
क्योंकि
Wikipedia,
मैंने
so
बेस क्लासिफायर तो उसमें से
by
ले
the
लिया
way,
इंपोर्ट
although I have
एसक्यूएल
not
में से।
mentioned,
नहीं
I
भी
अरे मैं
will
वही कहता,
always
हमें वो क्लासिफायर ट्रेन करना है पूरा,
sometimes I will take
मतलब
help from
एस्केलर्न जैसे करते हैं,
Wikipedia as well as
या
Investopedia,
फिर हमें ट्रेन
both.
करने की जरूरत नहीं क्योंकि
Okay,
हमें
just
प्रायर्स
to
वगैरह पहले से पता है।
get
अरे नहीं प्राइस की तो जरूरत है।
uh,
प्राइस तो बस ये मानना है कि हमको
definitions
बस
of
मानना है
these
कि
terms,
जीरो मान ले कि
okay, in their
0.95% या
sense. So
0.8% लोग देता
mainly
है
in
तो
Investopedia,
तब
if you look
सही
at
सही
that,
दे देता है तो
they
वापस।
हाँ
will
लेकिन वो जो
provide all these
0.8 है
definitions
वो हमें पता है
from
कि या फिर हमें
नहीं वो हमको मानना है।
डेटा सेट पे फिर से
economics
रिकैलकुलेट
point
करना
of view. Okay, and it is good
नहीं
to
नहीं नहीं वो
read
हमको
those
मानना है
things there also.
है। नाइस।
कि ऐसा है
But you
और
can,
डेटा सेट बताओ कैसे
I
बनेगा,
mean,
बस उन प्रायर्स के
take
ऊपर
help
एक
from
डेटा
any
सेट बनेगा
standard
तेरा।
books also.
हाँ बाकी फिर क्वेश्चन 1 हो गया
Okay,
मेरा,
so
बस प्रेजेंट करना है अच्छे से थोड़ा सा।
in statistics, what is a population? Actually,
तेरा
it is
मैं
a
बताता हूँ ना।
set of similar items or events. I mean, which is of our interest, or it could be, I mean, uh, for some experiment purpose. Okay, so population or statistical population, it can be a group of existing object that has certain properties. Okay, so generally it is difficult to work with whole population. Okay, so what statistician they will do, they actually instead of working with whole population, statistical population, uh, they try to work with a small collection of that population. Okay, and if that collection has certain properties, then we set that is a random sample from that particular population. Okay,
मैं देख रहा है
and the mean of that random sample is actually called sample mean, and the expectation
ये
or
सब है
the
नॉर्मल चीजें कर दी
mean
इंपोर्ट, ये
of that
प्रायर्स मान
population
लिया
is called
ठीक है।
population.
एक्सटेंड बाय करंट है ये तो
Okay,
डेटा सेट जनरेट कर रहा है।
so mainly, I mean, suppose
ये
a
ये तो सेम
population
ही
is
करोगे, ये तो
so
करने
of
नहीं करा था।
course so
थोड़ा सा लग
और
we
मतलब
need,
वो तो अपना मीन अलग ले सकते हो,
I mean,
स्टैंडर्ड
we will
डेविएशन
not
अलग ले
work
सकते हो।
on an arbitrary population,
मैंने
right?
ये ले ऐसे मेरे को इसकी फिगर
So
बना के
हाँ
it
दिखा था
must
सिर्फ मैं
be
0.8 और 0.2 लिया।
distributed
हाँ वो तो सर नहीं लेते थे, वो चलता है।
through a law.
ये
Okay,
डेटा आ गया, ये ऐसी ट्रेन
suppose you
जनरेट
have
इसमें भी करना
I
था, ये
mean,
क्वेश्चन 1 में भी स्प्लिट करना था।
a population
पता नहीं मैंने
uh,
कर दिया,
चलो ठीक है।
देखने में अच्छा लग रहा था।
that follows a certain
ये कर दिया
suppose
फिर क्या ये
although I have not told you
डिस्ट्रीब्यूशन
those,
करना था,
so
पता नहीं क्या फालतू का
examples of certain type of
क्या तो
distribution
सीधा
like
ये
normal
कुछ
distribution,
स्केल नाइव बेस
binomial
इंपोर्ट करवाया,
distribution, binomial distributions.
चल गया फिर वो
So I mean,
तो नॉर्मल चीजें करते करते
for
कंफ्यूज
instance, you
मैट्रिक्स
can
बना
say
जाओ
that you have a collection of random. By the way, why we have discussed random variables? Because we wanted
मैं
to
शेयर करता हूँ।
uh,
तो ऐसे कर रहा है, ऐसे ही
discuss
कर रहा है या फिर
or
अलग कर रहा है?
I mean, these random variables
Theoretically
make
लेकिन
our life
एस्केलर्न नहीं होता।
simple, isn't it? Instead of
कैसे कर
working
रहा है?
on a given abstract probability space, it is better to work on
मेरे
a
ख्याल से
simpler
एस्केलर्न यूज
probability
नहीं करना है,
space,
पर मेरे को लग रहा
okay,
है
that can be obtained
क्या ये
equivalently with the help of a random variable, isn't
यूपीएस
it?
अरे
And
वो
this is the reason why
मीन
we
है,
have defined distribution of a random
-1% एरर
variable.
1 और
If you have
1%
a probability space,
डेविएशन,
suppose omega and p,
ठीक है
and you have a random variable
और
x
यहाँ पे
on
ठीक है
this,
ठीक है
okay,
ठीक है।
then you
ये
can
क्या है,
get
बेस क्लासिफायर
another
है?
probability
ये x की वैल्यूज लेता है
space
और वो
R,
प्रायर मीन और डिविएशन
BR, where BR is the
और
Borel
बाइट
sigma
कर
algebra
देता है
on R,
कॉम्बिनेशन।
and PX, where PX is the distribution of the random variable x.
करना मेरे ख्याल से यही है।
Now, working in R,
मैंने फिर एरर चेक
BR,
कर लिया
PX
क्वेश्चन 1 के लिए।
is easy compared to working with the original probability
अच्छी करियो।
space omega and p, isn't it?
नीचे अभी
ये
फिर
ट्रेन
डिटेल
ट्रेन कैसे करा है तो? ट्रेन टेस्ट स्प्लिट कर दिया
वही
For
वही
instance,
पूछ रहा था
if
मैं
you
कि ट्रेन
look at
करने
the
की जरूरत है, क्योंकि
expectation,
जो ट्रेनिंग हो रही है ना वो पता क्या कर
or
रहा है,
so
वो डेटा सेट से पी यू और एस
okay.
फिर से
So
रिकैलकुलेट
that
कर रहा है।
was the one thing.
तो मैं वही बोल रहा था कि
kind of.
ट्रेन
Let me
करके हमें
just
रिकैलकुलेट
tell
करना है
you
कि
what is
यही वाला यूज कर ले।
a random sample.
हाँ नहीं
Okay,
भाई
that is
इसे हमने
drawn from
मांगने की कोशिश करी
a given population.
इसने दिया नहीं
Okay, for a particular study, say for example.
सर ने भी कुछ ढंग से लिखा नहीं है।
So I mean, I can write
जनरेट
it.
ट्रेन ही
द
कर
पॉइंट
I
लेते
think
हैं।
that will be the better.
क्या?
वैलिड बेस क्लासिफायर ना
So now I'm going
तो
to
एक
tell you the
क्लास
formal
इसमें
definition
ये
of
इसमें लिखा है कि
a random
ट्रेन
sample.
करना
Although I will not use the term random
है एक
sample
बेस क्लासिफायर वो
because just
करना
to
है
make the statement complete, okay,
लिखा क्या है एग्जैक्टली?
I will try to
इवैल्यूएट करना है
avoid
बेस
using
क्लासिफायर को
random sample.
तो
But
यही
whenever
तो
I
होता
say
है
that
इवैल्यूएशन होता है यही तो होता है
something
कि
is a random
उसका वो
sample
कर
means
देते
it
हैं
satisfies certain
एरर देखते हैं
properties. Okay.
हाँ
Simply, if I say that a particular
यही करना हो
collection
जाता है
of random variable x1, x2, and so on
ये बताइए बेस
xn is a
क्लासिफायर कैसे
random
बनाया था
sample, okay,
टू डेफ बेस क्लासिफायर
ये
where
हाँ
स्लाइड्स में जाके मैंने
xn
फॉर्मूला लिखा,
follows a particular distribution, okay,
तो वो दो चीजें कंप्यूट करके उसको कंपेयर कर रहे थे, मैंने कर
say
दिया कंपेयर।
क्यू क्यू
fx,
क्यू जीरो क्यू वन
okay,
क्या है
or
Q0
if the
ये
if
सब
नॉर्मल
the
नॉर्मल
PDF
डिस्ट्रीब्यूशन है
or PMF of that
ठीक है
random variable exists, then you can denote it by its PDF also, okay.
और ये वाई क्या है
If
वन और जीरो देगा बेसिकली
these random variables, so
हाँ
this
लेकिन
collection is actually IID,
अच्छा जो जो क्या वो
means
वो
they are
ग्राफ बनता है
independent and
अच्छा उसके
identically
अकॉर्डिंग देगा कि
distributed.
उसमें रैंडम वैल्यू मतलब थोड़ी वैल्यूज निकालेगा उसके अंदर से एक
So identically distributed means,
है ना ऐसे ही है
I
ना
mean,
थोड़ी
for
वैल्यूज
each
निकाल के
I,
अगर वो कम
xi,
आई तो उसके
the
साथ से
distribution of xi is
लॉजिक
equal to,
एनालिटिक्स
maybe you can say the probability
ट्रेन
distribution
करे कि
of
ना करे।
xi is equal to
छोड़
probability
नहीं करना
distribution of
मैं
xi.
अपने यही हटा दूंगा लेकिन दूसरे वाले में ट्रेन करना पड़ेगा
हाँ इस वाले में इसके लर्न करना पड़ेगा।
Okay,
अरे इसमें भी
and
मैंने
if
सेम चीज करी मतलब
since
जो इसमें करी है
uh,
मतलब उसमें 50% की एक्यूरेसी है
they
50
are
50
identically
और 50
distributed, it means they must come from
बताया था कल
a particular
इसमें तो इंपोर्ट करने में टाइम लगा था मेरे को,
population that
क्या
follows a particular,
क्योंकि 600 MB की
you
फाइल है।
can say,
अच्छा मतलब थोड़ा सा टाइम लगता
uh,
है हाँ
वही मैंने उसको लिमिट कर दिया 100 रोज।
I mean that follows a particular,
क्या
maybe,
पहले
what
3
should I
लाख
say,
कुछ रोज थे, अब सिर्फ
uh,
100 तक करा मैंने।
100 तक क्या इंपोर्ट करा है
so for instance, you can say
ठीक है क्यों भाई
normal distribution with parameter
जल्दी
mu
होगा
and
ना।
sigma square. By the way, since I have not told you these things,
अरे
but
ये
let me
वाला
just
भेजिए
tell you
बेस क्लास
what is
उसमें
a
भी देख
normal
लो कैसे
distribution.
करना है
You say that a random variable x follows normal
पूरा कोड
distribution,
ही डाल देता हूँ।
okay, with
पूरा कोड
parameter
डालो
mu and
पेज पे
sigma square.
एसक्यूएल हटाता हूँ
If
पहले
its
इसमें से जो मैं प्रॉब्लम
probability
निकलता
density function, or you can say its CDF, cumulative distribution function,
है
usually we
एक्सेल पे
denote by
कंफ्यूजन मैट्रिक्स से चलना है
nx,
वो तो बनेगी
is
नहीं
given by,
वो बोला भी नहीं बनाने को, ऑप्शनल।
oh sorry, it is standard. So let me just, otherwise you need to, let me take standard, that will be easy to work.
एक्स डेटा सेट है ना
हाँ एक्स डेटा सेट है, नहीं एक्स सिर्फ वो है, लेबल
Okay,
नहीं है मतलब।
so this is the
एक्स अच्छा
standard,
ठीक है
हाँ एक्स सिर्फ एक्स है
the
मतलब।
CDF of standard normal distribution. Okay, cumulative distribution function of standard normal distribution that has mean 0 and variance 1. Okay, similarly you can define, there are other distributions. Okay,
वाई पे तू अच्छा ठीक है वाई तो तू बना रहा है ना बाद में
all right, so
ठीक है
यार
let us look at
और
the statement.
पी क्या देता है स्मॉल पी
Before going to the
पी
statement, I
वो
think,
लिस्ट है उसमें P0 और P1 है।
अच्छा
actually I wanted to discuss something about. So I have told you the definition of expectation of a random variable. Okay. Now,
ये y
but
वाला
I
फॉर्मूला
haven't
क्या है
told
ये?
anything about
y1
variance.
into p0 into
So can
q0.
anybody tell me what is the
अरे वो
variance of a random variable? How will you define
ब्रैकेट
the
के अंदर
variance
चीजें
of a
वो
random
भूल गए
variable
इसलिए उसको 1 से मल्टीप्लाई कर दिया
in terms
ताकि
of
वो
its
इंटीजर बन जाए
expectation?
0 1 हो जाए
वो सबसे सही है उसका अंदर वाला
Expectation
फॉर्मूला
of
क्या है?
x square minus
पता नहीं जस्ट लाइक दो चीजें
whole
कंपेयर
square
करके
of
मैंने कर दिया
expectation, or maybe minus of this.
Exactly. Or
cos t के
equivalently, you
something
can
ऐसा
say
कुछ
that
है
it is x minus
ठीक है।
expectation of x whole square, isn't it?
और जो तेरा y है y
By
तेरा
the
वो
way,
देगा कितना?
usually we denote,
बाई लेबल होएगा फिर
I
Label.
mean, in typing, I will write this.
ठीक है।
Okay. Here, P means, I mean, our original space is, probability space is this. Okay. And x is a random variable from omega to r. Okay. So expectation of x means it is simply x. Okay. If suppose x is a continuous random variable, isn't it? Then you can
अच्छा,
write
आपका
this
पूरा code
integral
paste है।
in terms of its
क्या
probability
पूरा code
distribution.
paste है।
ओपी
उसमें
Okay.
थोड़े changes
Or
करूंगा मैं।
suppose it has a probability density function
ताकि standard
fx,
ये standard
then you
deviation
can
वगैरह
write
change
it
कर
like
दूंगा।
something this. And this is nothing but the Lebesgue integral of x fx over r. And you know that if fx is smooth enough, you can approximate it easily by using any numerical approximation technique. And one technique that will be an implication of law of large number called Monte Carlo method of approximating the expectation. Okay, so we'll see that application and we will see the implementation in Python also. Maybe I will give a certain assignments also.
और ये थर्ड क्वेश्चन कैसे करना है कुछ पता है?
All right.
मतलब करना है आपको?
अगर सेकंड टाइम पे होता तो कर लेंगे
And of course, if x is a discrete random variable,
डाल दिया सब
then
कुछ
ये भी ठीक है। ट्रेन
it will
टेस्ट
become
में इसके अंदर अच्छा वो दूसरा उसका
वो क्वेश्चन 2 के लिए डाला था
a discrete sum, right? Depending on the range of that random variable. If it is finite, then it will become a finite sum. If it is countably infinite, then it will become infinite, right? And here in this case, fx is called probability mass function, and actually it is given by,
ये रैंडम डॉट चॉइस क्या
so
करता है वैसे? 0 और 1 के बीच में
probability
वो कोई
x
चॉइस
is
करेगा?
equal to x,
p क्या है तेरा
isn't
ये?
it?
प्रोबेबिलिटी
In this case.
अरे वो मतलब
Okay.
मेथड में क्या है?
So it was just a quick
मतलब
revision
क्या
of the definition of
प्रोबेबिलिटी तुमने
expectation
की 0 और 1
and
को
of
कैसे
course
चूज करेगा
variance.
ऐसा?
By the way,
हाँ
there is a very, I don't know whether you have seen it or not, very important result. If you have two independent random variables,
ये x का फॉर्मूला कहाँ से है? एक की
ये तो वही है जो तुमने किया
okay, then
मैंने
the
इफ एल्स की जगह
expectation
वो कर दिया y इक्वल्स टू 1 इनटू
of xy can be decomposed in
एक 0 हो जाएगा कोई क्या ऐसा?
like this. Have you seen this result? Converse may not hold, but this can be proved.
ठीक है ये भी।
Okay, if not, then we will prove it. We will prove it for those random variables that are either discrete or
तो
continuous.
p0
Because in
अच्छा
that
p0
case,
वो है
we can write
x
this
to 0 की
expectation
वैल्यू
if it is
देख सकते हैं
discrete in terms of
वो नहीं होना चाहिए क्या कहता है
a sum, if it
जो
is
ऊपर लिखा
continuous in
था
terms
y
of
के उसमें
integral of
रैंडम डॉट चॉइस
certain
में
function, Lebesgue integral.
p1
Okay.
पहले नहीं आना
So
चाहिए
we have seen this result in our probability course last
Okay.
year.
अरे जब P0 था
We-
0.8 है तो
last year we
वही
have proved it.
करेगा ना कि probability की 0
Not
से left हो
your course.
मतलब पहले आ रहा है
Satyanath sir taught us probability.
तो जीरो भी तो पहले आ रहा
Okay, okay.
अरे नहीं तो
So
0
how?
का क्या सीन है
Okay. So do you know how to prove it
डिफॉल्ट करेगा या नहीं करेगा
in
No,
general?
sir,
पता नहीं
I don't
सर ने
remember
कैसे
that.
था
Okay.
ठीक है
So maybe you
सर का
please
copy
try
paste
to
कर लो
have a
मुझे
look on the proof of this result. Okay.
तो
So
जिसमें ज्यादा वो होगा P0
of
वो
course
जो
it
डिफॉल्ट
will
नहीं
be
करेगा
difficult to prove for any
हाँ फिर
given
डिफॉल्ट नहीं
random
करेगा
variable.
जीरो डिफॉल्ट नहीं करेगा
Okay, but you can deduce this result for particular type of random variable, as I said, if it is either if it is discrete or continuous. Okay, if you want to prove this for any given random variables x and y that are independent, then you need to use this abstract definition. Okay, so how you have defined this? You have defined it as supremum of integrals s, where s lies between 0 to x and it is a
दोनों
simple
सेम
function.
स्टैंडर्ड डिवीजन लिया ना
So what will you do? First you will prove it for simple functions. Okay, and of course this is defined if x is non-negative. So if you would like to prove this result for any two arbitrary I mean for any two given random variable that are independent, what you need to do, first you prove it for x plus y plus, okay, I mean for their positive components, and then combine it to get this result for any random variable. Okay, and of course if you consider x plus and y plus, you can give the definition of expectation by using this definition. Okay, and okay, let me say x plus. Okay, and similarly you can define the expectation of x minus, and after that you need to combine. So it is actually it's messy, so I don't want to give you the proof. Maybe I will share a separate write-up on this, and those who are interested to look at the proof for general case, you can look at that. Otherwise, if you consider a special type of random variables, discrete or continuous, then it you might be able to deduce it easy. Okay, so let's assume that. So since you might have proved it for the case of discrete random variables, isn't it? Then it will be easy to do this. Okay, in that case, this expectation can be written in the form of sum, isn't it? Either finite or countable based on its range set. All right, so let us postpone the proof of this result. Let us believe that, okay, it is true. Okay, and based on that, we will try to deduce the proof of weak law of large number. Okay. So before going to the proof of weak law of large numbers, let us look at what is the statement and what is strong law of large number and what is the difference between these two. Why the name weak and strong? So all right. So weak law of large number says that if you have, I mean, by the way, you should always keep in your mind that you are working in one universe. Okay, means you are working in a given probability space omega mp, because once you vary it, it will be very difficult to handle. Okay, so for instance, you might have some of you must have seen the Bertrand paradox, right? So for the same problem that is given as a sentence, okay, one can get three solution, okay, three distinct solutions. And the reason is that reason for those three distinct solutions is actually those three persons are working in three different universe. Okay, once you fix the universe, you will get the uniqueness. Okay, and this is the reason why we always try to fix this probability space omega and p. Once you fix it, you will not face any trouble of such type of paradox. But if you not fix it, then of course you have n number of paradox. Okay, so you for whole probability, I mean course will be actually full of paradox. So it is better to fix our probability space and then work on it. Okay, so this is the reason why I always try to write this probability space. Okay, so well, let us go to the here. So if you have, I mean, a probability space omega mp, and suppose you have IID random variables x, x1, x2, and so on, xn. So IID means these x, x1, x2, x3, and so on, they are independent and identically distributed. Means the distribution of x will be equal to the probability distribution of xi for all I. Okay, or you can say that if these random variables have
नहीं वो भी के लिए 20
density
बाद में
function
end कर दूंगा.
or probability mass function, then you say that they are identically distributed if their PDF or PMF are same. Okay, or equivalently you can also say that these are identically distributed if, so these are consequences. Okay, this is the definition. With the help of this definition you can prove these results. This is CDF, so this is PDF, probability density function, or PMF, depending on whether it is continuous or discrete random variable. And of course, this we denote a CDF means cumulative distribution function of a random variable x by capital F. Okay, if they are drawn from this. So this is the reason why we usually, so this actually will give you a random sample. Okay, x, x1, x2, x3.
हाँ ये तो बात बताइए x क्या था इसमें?
Okay.
Base classifier ना? Def base classifier.
So if you have such type of
X क्या था?
IID random variables with
X.
one
number,
property,
real number.
and that is this. Their mean is
Norm.pd.
finite.
ऐसा कुछ था time between
Expectation.
paid and deadline.
So you can say that expectation
Extra
of
वो नहीं
x
होता?
or
कितनी
xi
range में से करना है तेरे को?
exist. Okay,
मतलब
mean of mod x is finite. Okay, it means
That's what-
this quantity must exist, whether it is I mean
कैसे करते हैं?
non-negative or any real valued random variable.
तब bro
Isn't
मेरा हो
it?
चुका है आज का.
Okay. So under these conditions, for each epsilon, positive epsilon, you can prove that the probability of the event, this event, okay, so it will give you a sequence of probabilities, right? So you can say that it will give you a sequence of real numbers, right? So this you can denote by some event En. Okay, let me write it here. It is better to mention epsilon also. En epsilon omega belongs to omega such that this relation hold means mod 1 by n summation I is equal to 1 to m xi omega minus expectation of x is less than epsilon. So this is an event, isn't it? So weak law of large number says that the probability of these events in the limiting case, so limit n goes to infinity, is actually 1. Okay. So this type of, so it is a special type of convergence called convergence in probability. Okay. So in this sense, weak law of large number says that the simple mean converges in probability to population mean. Okay. So this is the population mean, and this is simple mean. The next, okay, any doubt in the notation or because here the notation is very, I mean it's a very strange
ठीक है कुछ समझ में नहीं आ रहा मेरे को क्या लिखा है ये।
notation, so I don't know what should I remove. Yeah, so let me ask. Ramdas? Yeah, oh, there is some. Okay, Nahan. Yeah, Ramdas, can you hear me? Yeah, any doubt? All right, okay. Yes, Narnovari? Okay, great. So it means I mean, there is no doubt. So I think you might have seen these results. That's why. But although I mean it seems very trivial, sometimes people use it in a
अरे
very
इधर तुम्हें ये
vague
फॉर्मूला
way,
कौन सा
and
उससे निकाला था
that leads to something
सा?
called
लेक्चर
Gambler's
वगैरह या कौन सी
fallacy.
पीडीएफ से
Okay. So we'll discuss what is Gambler's
ये कंपेयर
fallacy.
कर रहा हूँ शायद
हाँ।
फोर्थ लेक्चर
Okay. For instance, if you suppose
लेक्चर है
toss a fair coin,
जिस
okay,
दिन लैब या तो उसके
5 times, and suppose all the 5 times you got head. Okay.
ऐसे
हाँ।
डेट पूछ रहा हूँ
24th
What is your guess at the next toss? Anybody? You can write in the chat window. The question is, well, you have a fair coin, that is clear.
ठीक है
Okay. The probability of occurrence of a head or tail is equal, means it is 1 by 2. Okay. Now suppose you have tossed that coin 5 times. Okay. And all the times, or you can say, okay, out of 5 tosses, you got 4 head and 1
एरर
tail.
भी तो कर रहा है एरर भी भेज दियो
Okay, maybe the first toss was tail, and then
इसने एरर इससे एरर कर पहले इनको चलो और
other consecutive tosses was head. Okay. What is your guess for next toss? Mahendra, head again,
डाल दिया इसी में
head
मैंने।
again, head and tail. And Nishant, what do you mean by head oblique tail? It could be anything. I mean, what is more probable? Let me just make it like this. I mean,
क्लासिफायर कहाँ से आया?
isn't it?
डेटा क्लासिफायर
क्या?
टू क्लासिफायर क्या था ये डेटा
Okay.
बेस क्लासिफायर
अरे जो फंक्शन है उसका नाम, हाँ।
Okay, suppose again at the sixth toss, again you got head.
जो hypothesis
Not only
function
6. Okay.
क्या?
Next
जो
100
hypothesis
toss,
function
you
होगा
got head, head,
इसका
head.
जो होता है
बेस क्लासिफायर, रैंडम क्लासिफायर।
What will you guess at 101 experiment or trial?
Sir, actually, every new experiment is like itself, like it is independent of its previous experiments.
और तूने बस
Exactly.
उसमें वो करा है
So,
नीचे वाले में
but some people
random वाले
can
में
guess. I mean, some of you have written
सीधा
that.
से ली
Yeah, if it
किया
is a fair coin.
जो आ रहा है वही
रैंडम
आंसर है
जनरेट
Okay.
कर दिया।
अच्छा
So actually, I mean, you can misinterpret this result like this. Okay, since it says that the sample mean converges to the population mean. Okay, so although it's very difficult to relate that, as I told you, the historical probability or frequentist approach or empirical probability with law of large number, we will discuss how to relate it. Okay, so their approach is that, okay, if you draw a particular coin, if it is fair large number of times, okay, the amount or the occurrence of head, okay, number of heads will be approximately equal to the a number of tails. Okay, so that will give you the probability in some sense of occurrence of head is actually approximately half, and the probability of occurrence of tail is approximately half. So this intuition actually will come from the law of large numbers. So I mean, you can approach that frequentist. I mean, you can you can relate that frequentist approach of probability with the axiomatic definition that you have given. Okay, because this axiomatic definition will not give you, it will just say that, okay, that is actually a probability model. Whether that model is correct or not, we don't know, isn't it? So to check whether that model is correct, you need to do some experiment, and that experiment can be done by using several approaches, and one of those approaches actually is this empirical probability, the notion of empirical probability. So anyway, we'll discuss that again. So I have seen two very important application of this. One is approximating the integral, means expectation, okay, and other one is justifying the frequentist approach of defining the probability. All right. So before going to the proof of this result, since you do not have any problem in the statement, let us go to the strong law of large numbers. It says that the simple mean converges pointwise to the population mean almost surely. That is strong, isn't it? And theoretically, you can prove that the almost everywhere convergence actually imply convergence in probability, but converse may not hold. Okay, and this is the reason why we say that it is actually strong compared to the previous one. Because if this convergence hold, then you can say that, well, it will certainly converge in probability to the population. Okay, means this will certainly hold. And the best thing is that if you look at the assumptions, what we have assumed here, the only assumption is that the population mean is finite, isn't it? This is finite. There is no additional assumption in both the statements. Of course, this is one more assumption, means these random variables are IID, but this is important. And to prove these results under this assumption is actually it is quite involved. Okay, so I don't want to give you the proof under this weak assumption on the data. Okay, what I will do, I will prove this result with one additional assumption, and that will make our life very simple. Okay, so what will be that additional assumption? We say that the variance or the second moment is finite. Okay, so anyone will work. So of course, once you say sigma is square, sigma is a real number, it means it is finite. Okay, with this, a simple application of Chebyshev inequality will give you this result. Here, in case of strong law of large numbers, we will use a little stronger, will impose another condition, expectation of this is finite. Okay, although these are not needed, okay, but in that case it will be, I mean, it will utilize full measure theory. Okay, so I don't want to go to that because I have already discussed basic things, and maybe if you are interested, you can look at any standard book, okay, to prove this result with this assumption only, without using this assumption, these stronger assumptions. Okay, another result, suppose you know that, okay, that simple mean converges to population mean, and in certain sense means in case of strong law of large number, it converges point-wise almost surely. By the way, let me discuss what is almost sure convergence, right? So again, you write this event. So what is this event? So little omega belongs to the sample space such that limit n goes to infinity summation I is equal to 1 to n xi omega minus, so population mean is G. Okay, collect all those points of the sample space omega at which this sample mean converges to population. Okay, once you fix omega, this xi will give you a realization, right? Isn't it? Of that random variable. So, strong law of, in short, we say it is SLLN. Okay, so SLLN says that the event, I mean, the probability of this event is actually 1. Okay, this event is going to occur. It is sure that this event is going to occur. is going to happen. Okay, the probability of occurrence of this event is 1. Now the probability of its complement is actually 0. Okay, so how you have defined almost everywhere convergence in major theory, right? The same idea is here. So equivalently, this definition, this sample, so this is called sample mean. Sample mean converges to population mean almost surely means probability of the event. This is 1, okay, and that event is given by this. Okay, equivalently, you can say that the probability measure of the set of points at which this simple mean doesn't converge to population mean is 0. Okay, so in major theoretic view, we say that it is called almost everywhere convergence. Okay, but you just, if you rewrite it like this, then you can say that it is almost sure convergence. Okay, because the probability of this event where this convergence is happening is actually 1. Okay, so that's, I don't know. Okay, let me ask any question in the statement or any doubt. Okay, so okay, let us look at another important result called central limit theorem. Okay, so from law of large numbers, so that is weak or strong. Okay, what you have seen that if you have a random sample, then from a population, then the sample mean converges to population mean, isn't it? In certain sense, depends on. Okay, and of course, under one condition that the population mean must be finite. Once you have that, you might be interested what will be the distribution, isn't it, of that of the limit of that simple mean, isn't it? So that can be, that question can be answered with the help of central limit theorem. Okay, suppose you have a collection of independent and identically distributed random variables with mean 0 and variance 1. Of course, you can always standardize. Suppose you have any other collection, okay, y1, y2, and so on, yn, of independent and identically distributed random variables. You can define, you can standardize it, of course, under the assumption that suppose the mean, population mean is mu and the variance is sigma square. You can standardize it, and what you can do, you can define this is y. Okay, xi yi minus mu divided by, I think, what will be the expectation of xi? Of course, it is linear. expectation of mu, it will be nothing but mu. And what is this? So it will give you 0, right? Now you find the variance of x I. Okay, if it is 1, means this will give you the standardization of this collection of IID random variables. Tushar and Satvik. You said something, no sir, okay. What is that?
Sir,
it
no,
was-
no doubt, sir.
Okay, okay. By the way, is this correct? This standardization of these random variables? Is this the
Yes,
way
sir.
you standardize it before implementing? Okay.
Yes, sir.
All right. So suppose you have such collection of IID random variables, you can standardize it, and then that will give you another collection of IID random variable with mean mu and variance 1. So without loss of generality, you can assume this, right? So instead of working such random variables, we will work with this special type of random variable, standardized. Okay. Now, if you have such random variables, then the cumulative distribution function of these random variables will actually converge pointwise, okay, to the cumulative distribution function of standard normal random variable. Okay, means the limit of fn y is equal to ny for all y, where ny is the cumulative distribution or CDF of standard normal variable. Okay. So yn, so it is not actually the simple mean. Okay, it is actually square root n times of simple mean. Okay. So if you consider simple mean, then it will go to 0. So you will not be able to visualize what is the limiting distribution. Okay. But if you consider this, it is also called statistics, simple mean, simple variance, such type of combinations. This is called statistic. Okay. So this particular statistic, the distribution of this particular statistic actually converges to the distribution of standard normal variable. Okay, and this convergence is pointwise.
Excuse me, sir.
Okay. Yeah.
So sorry to interrupt. Actually, our another class is
क्लास
started.
खत्म हो गया इसकी
Okay. Thanks. Thanks, Tushar.
सेंट्रल
So maybe tomorrow we'll discuss some examples. Okay.
Okay, sir. Bye, sir.